produce more hydrogen offshore, we have to bring that hydrogen onshore. Can we do that in the existing pipes? Do we need new pipes? And what should we all consider when we think about pipes? Please welcome Bart Steuten of Strohm. Bart, good morning.
Good morning.
You're
Good morning,
product development manager at Strohm.
Yes.
You make pipes. What is so special about a tube for hydrogen? Can it be? Is it just the same tube I have at home for my natural gas, or is it a completely different thing?
It depends on the application, of course. Are you onshore or offshore? But at home, you can use your existing gas pipes, polyethylene pipe, nylon pipes, works fine. That's also the beauty about hydrogen. We can introduce it in our natural gas network. But for onshore, it's a different ball game. You need a pipe that is easy to install, that's robust, and it has a long lifetime under a high and fluctuating pressure, and that can withstand hydrogen and does not degrade under hydrogen. And
so it is prerequisites. Is it because of the hydrogen in the tube, or the sea and the seabed outside of the tube?
It's both. It's both actually, because hydrogen in the tube can cause hydrogen embrittlement if you have steel as your main material, and that's amplified if you have fatigue stresses in a dynamic environment, which the sea is very dynamic. Then steel pipes are not the best solution, because hydrogen embrittlement will ultimately destroy your pipe. So you need a material that is capable of or that does not degrade under hydrogen as a fluid inside. And that's a composite material, does that. It has no fatigue, it has no, the hydrogen has no impact on the fatigue life and the design life of the pipe. And the other aspect of being offshore is that you need to be able to install the pipe. So a steel pipe is, we install steel pipes offshore, we build large, big trunk lines offshore. That's fine, it works for steel, these are static pipelines. But if you have to connect multiple wind turbines, or if you have to connect platforms, you want to have a more flexible solution that's easy to install. And that's what our pipe can do.
Yeah. Okay, so this afternoon, René Peets of TNO, he's coming to explain to us we should have and probably will have much more offshore hydrogen production than we think right now, because of a variety of reasons. A few of those reasons are pipes are cheaper to install, faster to install, they are less bad for nature and environment, and we can recommission a lot of the existing pipes that we already have, and we can use them to store hydrogen because we need a lot of storage. With you, I want to go over all these arguments and see, are they true or not, and if so, what are the things we should think of? So first of all, the idea is first, do you agree we probably will have much more offshore hydrogen production than we think right now?
I think we will do, yeah, because we will find out that offshore hydrogen production in the end will be cheaper than producing it onshore. It's more efficient. You directly generate hydrogen at the location where the energy is harvested, at the wind turbine or at your solar panel that's floating out there. So you need less energy conversion if you directly convert it to hydrogen at sea. So that's one aspect. The other aspect is indeed transportation is much more efficient.
And do all these benefits offset the downside of building a huge gigalyzer onshore is cheaper than building smaller electrolyzers and build them on sea?
Well, to build that gigalyzer offshore, you first need to get the electricity. So to build a gigalyzer onshore, you need to have the electricity onshore. And we know now that getting the electricity onshore is also not very cheap. You need also giga installations. TenneT is building these 2 gigawatt converter stations offshore. They need these large HVDC electrical cables to line. These are also gigantic constructions. So, and the beauty of the concept of doing it offshore is that you can do away with those platforms. You don't need them. Especially if you go to the decentral concept that is shown on this video, where you put the electrolyzer directly on the wind turbine. You already have your monopile, so you have a platform already. You add the electrolyzers to it. You have to do a little bit with your electrical system on the wind turbine, of course. but then you have your hydrogen produced offshore, apologies, but very efficient.
Okay, we're going to talk more about this with René Peters this afternoon, so check out that video later. If we assume we are going to have much more offshore hydrogen production, one of the arguments is it's cheaper. The first argument is it's cheaper to lay pipes than cables. Is that true?
Well, it is true because you need less pipes. I think the laying process of laying a cable and the laying process of laying a pipe is fairly identical. Well, we showed it here by showing that you can lay our pipe with a cable lay vessel. So the costs are the same, but you need less cables to be installed than, less pipe to be installed than cable.
Is that only true if we really compress the hydrogen?
If you do not compress the hydrogen offshore, you will need bigger size pipe to transport the same volume of hydrogen. But the size is not really the determining factor in the cost. Yeah. Not in the installation. Okay, so
that's cheaper than damage to the environment. If we dig things in the seabed, are pipes better than cables?
I think that's a difficult question for me. I would think there the benefit would be that for a pipe you only need one pipe. Again, you only need to have one pipe. For a small pipe you want to bury it, you need to bury it. Same as an electrical cable. For big pipes, large trunk lines, you don't need to bury them. So these indeed will have less impact on the seabed. Yeah.
Of course, the biggest environmental and also maybe time advantage is if we can reuse existing pipelines. Are we overestimating the abilities for that, or is that really possible?
I think it's a very good solution if you have a pipeline that's in the area where you want it, and the integrity of the pipe is there and is demonstrated, then it's the best solution that you can use. It's cheap, and it's there already. But in the end, the pipes are never at the right location. Sometimes they are, but generally not the case. But yes, if that works, then do it, yes. But still you need to connect, of course, your platform to that pipeline or your wind turbines to that pipeline. So you will need new pipelines anyway.
You will need new pipelines. But in the situation where there is an existing pipeline, the exact location where we want it, can we just reuse it, or we need to replace it anyway?
We could reuse it if the condition of the pipe is good, and if the condition of the pipe is not good, we can do a pipe-in-pipe solution for it. So our pipe lends itself perfectly to do an insert into an existing pipe. If the pipe is big enough, we can do a pipe-in-pipe.
Another argument to produce offshore is for storage. When there's a lot of wind, we produce a lot of hydrogen, we pump it into the pipes, and when the demand is high, we can take it out. Is this a significant storage, or is this peanuts?
It depends on your time frame. If you look at day-to-day, yes, it's significant. If seasonal storage, no. But line packing is indeed a big advantage of pipelines compared to electrical cables, yes.
But with wind coming and going, day to day, it's going to be very important, isn't it?
Yes, yeah. So it is significant for the short term, yes.
If we use the pipes as storage, that means we're going to increase the pressure on it during certain hours of the day. What does that mean for the quality of the pipes we're going to need?
Well, that's the beauty of composite pipe. It will not suffer from fatigue. The materials used in composite, glass fibers or carbon fibers, are excellent in fatigue. The airplanes that we fly in, they're built from carbon fiber because of the good fatigue properties of carbon fiber. So carbon fiber and also glass fiber pipes can have a lot of fatigue load, an internal life almost in fatigue. So that's also the big difference between steel and composite pipe, line packing and fluctuating pressures are no problem for composite pipes.
Yeah, if you go to this kind of well-known Swedish manufacturer of chairs, you see this machine, it's press the chairs, and it says you can sit in this chair 1 million times. Same with your pipes, you can inflate and deflate them twice a day for years.
Yes, we try to prevent inflating them, but they stay round and they will not grow in size if you pressurize them.
But you can pressurize and depressurize them.
Yes. For 30, 40 years, daily, no problem. Yeah.
if you're really going to ramp up offshore energy production, hydrogen production, are you able to ramp up your production of pipes, or is pipes going to be the bottleneck of the transition?
We will make sure that pipes will not be the bottleneck. In our current factory, we will not be able to supply the volume that will be needed. We're talking about hundreds of kilometers. Our current facility doesn't have that, but we have a technology that's very easily scalable. So we have a relatively low capex facility, so it's compared to what you would need to make steel pipe or other pipe types. So yes, we can easily scale up because we can build a factory with little investment and in a quick turnaround time. We estimate that it takes about a year to build a factory of ours that we need from start building to commissioning.
Because we talk a lot about uncertainty in the market. We don't really know where it's going, and we have fluctuating policies in it. I heard possible owners of wind farms saying, well, we can adopt pretty fast, but in our value chain, our suppliers, we need to tell them in advance, because else we have a supply problem. For you as a supplier for crucial parts of the energy transition, how important is it for you to have a foresight of a year, 2 years, 5 years, 10 years where we're going, or uncertainty?
Well, we are used to live with uncertainty. Where we come from, basically 10 years ago, we started with this pipe concept, introducing it into the oil and gas industry. We've been living a long time with the uncertainty of being accepted as a solution, because the quality criteria and the guarantee that you can offer as a client that your pipe will not fail made it that it took a very long time for us to build up trust in the industry to have this concept accepted. So we have to live with this uncertainty already for a long time, and I think we can prolong it a bit longer to the hydrogen space as well. We're simply providing the solutions that we have, counting on that it will pick up, because we believe in this, and I think everybody agrees that we should go to offshore hydrogen. So we need this kind of technology. But when it will happen, if it is next year or in 5 years or 10 years. Yeah, we hope the sooner the better, but the uncertainty is there. Yeah.
Last week I was at the European Hydrogen Week in Brussels, where we talked about the European hydrogen backbone, and they showed this map of pipes under the North Sea to connect all the countries around the North Sea as a vital part of the European hydrogen backbone. Should it be your pipes?
Well, if that's the same graphic that also shows the wind parks that were alongside that pipeline, our pipes will connect the wind farms and the platforms to this large offshore backbone. I don't see our pipe as that backbone, because it will be a very large size pipe, 30, 40 inch. Our pipe technology is a bit smaller than that. We go to 8 inch at the moment. So it's perfectly suitable for to connect platforms, to connect wind farms, but for an offshore backbone, it's unfortunately a bit too small.
And a few years and you have that as well, or just your material is just not made for that?
No, the material is not the problem. It is that composites are generally lightweight, and these large pipelines, they're hollow, and hydrogen is lightweight. So you need to compensate for the weight, and we can do that for the smaller diameters. For the big diameters, that's an issue. So we think that steel there provides, because these backbones, these are static pipelines, right? They are there, they are always under pressure. So that's perfect, that works with steel. But the tie-ins, I see that happening, that this will be our pipe.
More your pipe. Okay, well, a body with a backbone with no other bones is not a useful body, so I hope you will provide some of the useful bones next to the backbone. Yes. Thank you so much for this.